Right, so today we talked about polyhedra. Polyhedra is the plural form of polyhedron, which basically just represents a three-dimensional figure. So at the very top it says, here are pictures that represent polyhedra. So these are your examples at the top. Here are pictures that do not represent polyhedra, so a sphere, a cylinder, a shape that's not enclosed all the way, and then a box that's open without a lid. So we talked about different objects and then we classified them. That's number one. So number two is we're talking about the features of a polyhedron that help us identify it. So polyhedron are composed or made of polygons. That's one characteristic. Polyhedron are made of polygons. Therefore, that's why circles aren't polyhedrons, because a circle is not a polygon. Another thing about it is that polyhedrons always enclose a three-dimensional region. So the two most important things is that polyhedron are made of polygons that have faces, so that we can add that have faces, and that polyhedrons always enclose a three-dimensional region. So the region actually has to be enclosed. So those are the two things. We talked about a couple more, so that polyhedron are not round, right? They don't have a spherical shape. Those help you distinguish a polyhedron from the other polyhedra from the other figures. But the most important things are that polyhedron are made of polygons that have faces, and that polyhedrons always enclose the three-dimensional region. So that's the first part from today. The second part of this asks us to look at prisms and then look at pyramids, and then ask us what are the characteristics or features of prisms, and then what are the characteristics or features of pyramids. So at the top, notice that in prism there's two sides that are identical to each other. So it has two faces that are identical to each other that help us classify it. And they're connected, those two faces are connected by rectangles. So they're composed of rectangles on sides, and that's what forms a prism. So a prism, characteristics that we need to know is a prism has rectangular faces, a prism has rectangular faces, and some has rectangular faces that are connected to two faces that may or may not be rectangles. So a prism basically is connected by rectangles, and it has two faces that are identical to each other, and so we're going to add that two faces are identical to each other. For a pyramid has a special face called the base. So looking at these pyramids, notice that the bottom, which is known as the base, can be different, and that bottom indicates what type of pyramid we're looking at. So all these are pyramids, but for this one, because the base of this is a triangle, it's called a triangular pyramid. This one is called a square pyramid. This one is called a pentagonal pyramid, and this is called a hexagonal pyramid. So a pyramid has a special face called the base. The base is connected by triangles that reach a peak or vertex. Right, so that helps us distinguish between prisms and pyramids. Moving on, we talked about these nets. It says, which of the following nets can be folded into pyramid P? Select all that applied. So in this example, if I use this middle part as the base, if I fold this upwards, if I fold this in, and this in, and this in, that's going to form a pyramid. And talking about this, so net 2 works. Net 1, if I use this as the base and fold this upwards and this upwards, this is going to swing around and be, or swing around this way, and will be that other side. So this one you can fold as well in order to make the net. It's much easier to actually do it on paper, but for this one, net 1 and net 2 make pyramid P. All right. Now it says that we need to be able to identify polygons that are composed of these shapes. So we're going to go back here. We're going to talk about the polygons that are that make up these polyhedron. So in this one, for a triangular prism, 2 triangles and 3 rectangles. For B, there are all 6 squares. For C, 2 triangles and 3 rectangles. For D, we have 2 pentagons and 4 squares. 5 squares, my bad, 5 squares. 5 squares. My brain is going faster than I'm writing. For E, we have 2 squares and 4 rectangles. And then for F, we have 2 hexagons and 6 rectangles. Okay, and then for the pyramids, we have for P, 4 triangles. For Q, we have 1 square and 4 triangles. For R, we have 1 pentagon and 5 triangles. And for S, we have 1 hexagon, 6 triangles. Okay. All right, so after that, after doing this, what we need to really focus in on is I want you to understand that based off the base or the shapes that define these is going to tell you how many rectangles are connected to them. And so that's something that you need to be able to pay attention to and be able to explain. Moving on past that, right? So one thing that we didn't talk about is what is the smallest number of faces a polyhedron can possibly have. It is 4 faces, and that forms a triangular pyramid. And then we skipped over that, and then we went to this part on the back. So we talked about, remember on Friday we talked about surface area, so we're really trying to focus in on understanding surface area. So for this activity, we're going to look at the nets and tell me what, and name the polyhedron that's composed of that, and then we're going to find its surface area. So for A is a rectangular prism. B is a square pyramid. And C, if you look at C, C has two identical, right? Two identical triangles, therefore it's a triangular prism. Because it has two faces that are unique, right? Triangular prism. Now to find the surface area. Remember, surface area is finding the area of each individual side. So I'm going to start here at the bottom. I'm going to ask you how many squares are inside of this shape. Well, I know that this is 6 by 5, so that's doing 6 times 5, which is going to be 30. So I do 6 times 5, which equals 30. Now know that if it's a rectangle, it should have another base that's identical to that, or another face. So this one right here is also 30. So really, 6 times 5 times 2, which gives me 60. I'm going to use 60 as part of my answer. Then I'm going to choose another rectangle. I'm going to choose the one that's directly above this 30 that I started out with. I'm going to count how many. 1, 2, 3, 4, 5, 6. So remember, the one parallel or opposite of that, parallel to it, should be also 6. So I'm going to do 6 times 2, which is 12. And then I'm going to do the last one, which is 1, 2, 3, 4, 5. That's 5 times 2, which is 10. Then I'm going to add 60, 12, and 10. And I'm going to end up with 82 square units. For problem B, what I'm going to do is I'm going to find the area of the square in the middle. That square is a 4 by 4. Therefore, that tells me that that's 16. Now, the thing, it's a square pyramid, so all those triangles should be identical. So I'm going to find the area of one triangle. Remember, to find the area of a triangle, we do base. The base of this triangle is 1, 2, 3, 4, times height, which is again 1, 2, 3, 4. I'm going to do 4 times 4, and then I have to divide it by 2 because a triangle is half of a rectangle, half of a parallelogram. So that is 16 divided by 2, which equals 8. So each one of these triangles is 8. So to find the surface area here, what I'm going to do is I'm going to do 16 plus 8 times 4. 8 times 4 is 32. Add 16, and you get 48 square units. Now on C over here, to find the surface area of C, what we're going to do is we're going to first find the area of the square. That's a 3 by 3, which makes that 9. Then I'm going to find the area of the rectangle below, which is 4 by 3, which is 12. Then I'm going to find this area, 5 by 3, which is 15. When I say 5 by 3, I'm saying 5 times 3. Now I'm going to find the area of one of these triangles because they're identical to each other. So this is 4 times 3, which is 12. Cut it in half, 6. 6 over here, 6 over here. I'm going to add those numbers up. So I have 15, 12, 9, and 6. When I add all that up, 5 plus 2 is 7, plus 6 is 13, plus 9, and then plus another 6. So 15 plus 13 plus another 6 is 19. 19 plus another 9 gives me 28. And then 2 plus 2 is 4. 48 square units. Now I know I stumbled through that math. So I would normally break this down as 15 and 12 first, which would give me 27, and then add 9, which give me 36, and then add the 12 together, the 6 and the 6, which would give me the 48 as well. So the surface area for this problem is 82 square units. Surface area is 48 square units. And then the surface area for this is 48 square units. And then the vocabulary from today is we have face, net, polyhedron, prism, pyramid, vertex, and edge. An edge is a line segment in a polygon or polyhedron. A vertex is a point where two edges meet in a polygon or polyhedron. A pyramid is a type of polyhedron that has one special face called the base, connected by triangles. To form a peak. A prism is a type of polyhedron with two parallel faces that are identical copies of each other. Okay, a polyhedron is a three-dimensional figure with faces that are polygons. A net is a 2D representation of a polyhedron. And a face is any flat surface on a 3D figure. So these are the notes from today. Yes, it's long, but to get through all that stuff, we kind of have to explain and be able to walk through, and it's mainly because the vocabulary is so long.